All right, today we are diving into a concept that is, well, it's pretty out there. It's an idea that asks us to totally rethink what we mean by the word real. It's a framework called Contraint Ontology, and trust me, it might just change how you look at, well, everything.
So let me just start with this question to get us going. What if the universe isn't actually made of stuff, but of rules? I mean, what if the laws that govern reality are more fundamental, more real than the stars and the planets and even the particles that have to follow them?
So where do we even begin with an idea that big? Well, funny enough, we're going to start with a really surprising problem that comes from the absolute heart of modern physics, from Einstein's own famous equations for gravity.
Yeah, you heard that right. According to physicist and philosopher J.B. Manchak, Einstein's incredible field equations for general relativity are, on their own, empty of content. Now, what does that even mean? It means that by themselves, they can describe literally any universe you can imagine, including ones that are complete nonsense. They don't have any real-world meaning until you start adding rules.
So how do physicists get these beautiful equations to actually describe our universe, the one we live in? Well, they add constraints. They have to step in and add rules, like, energy has to be positive, or that a cause has to come before its effect. And you definitely can't have these bizarre, unphysical holes just popping up in the fabric of space-time. It's only after you put these guardrails in place that the equations suddenly snap into focus and start describing a reality that makes sense to us.
Here's a great way to think about it. Most of the time, science is busy studying the pixels of reality. The actual stuff we can see and measure. But this whole idea suggests that maybe the real action isn't in the pixels at all. Maybe it's in the code, the deep, underlying set of rules that tells the pixels how to behave in the first place.
Okay, so that's the physics side of things. But what's truly wild is that this idea of rules being the most important thing, well, it doesn't just show up in physics. It pops up in the purest, most abstract of all sciences, mathematics. And it leads to something that people have literally called a miracle. So check this out. On one hand, you have number theory, this super abstract field that studies the strange patterns of prime numbers. And on the other hand, you've got nuclear physics, which is trying to make sense of the incredibly messy, chaotic world of energy levels inside a heavy atom. I mean, you couldn't pick two more different fields, right? Or so you think. So back in 1972, the famous physicist Freeman Dyson meets up with a mathematician named Hugh Montgomery. They start chatting, and Montgomery shows him some of his work. And what Dyson saw was so unexpected, so completely profound, that the only word he could find for it was a miracle. So what was this miracle? Get this, a really complex formula that Montgomery had come up with to describe how prime numbers are spaced out was a perfect one-to-one match for a formula Dyson knew from his work on the energy levels in atomic nuclei. And I mean, it wasn't just similar, it was the exact same equation.
Now, this is a perfect example of what this theory calls constraint convergence. This isn't like us seeing a face in the clouds where our brain is just imposing a pattern that isn't really there. No. As you can see here, this was two totally independent lines of research arriving at the exact same mathematical structure. This wasn't a guess. It was quantitatively exact. It strongly suggests they both stumbled upon a real, deep, underlying set of rules. And that is huge, because it hints that maybe mathematics isn't just something we invent in our heads, but something we actually discover.
So you've got this puzzle from Einstein's equations, and then you have this mathematical miracle connecting primes and physics. What if they aren't separate, weird things? What if they're both pointing towards a single, really powerful new idea about the nature of reality itself?
And that idea is called Contraint Ontology. And here's the core of it. It proposes that reality isn't really made of stuff, of substance, and it's not just some chaotic random process either. Instead, reality is generated by a fundamental set of rules, limits, and boundary conditions.
This whole thing basically boils down to three core ideas. First, the constraints. The rules themselves are what's primary. They come first. Second, objects. Things like an atom or a planet or you aren't stuff. They are stable solutions that satisfy those rules. And third, process, what we call change or the flow of time, is just moving from one possible solution to another, navigating the landscape of what's allowed by the constraints. Let's make this a little more real. Think about a hydrogen atom. We picture it as a little proton with an electron whizzing around it. But in this view, a hydrogen atom is the stable solution that pops into existence when you satisfy a specific set of rules, a specific set of constraints. Things like the electric force between them, the Schrödinger equation, and all the weird quantum rules. The atom itself is basically the answer to a math problem posed by reality.
All right, but the real test for any big theory of reality is to see if it holds up in the most extreme places we know of, the places where all our normal ideas about physical stuff just completely fall apart.
And this is where the idea gets truly profound. Think about a singularity, like the Big Bang or the center of a black hole. Our physics tells us that at that point you have infinite density and zero volume. The very concept of matter, of substance, of space, and even time, it all just dissolves. It becomes meaningless. But you know what doesn't? The rules, the constraints, they persist.
So, maybe a singularity isn't a tiny little point of infinite stuff at all. Maybe it's better to think of it as just a pure, naked set of constraints. Things like the laws of conservation, which say energy can't just appear or disappear, or deep mathematical properties of shape called topological invariance, or the boundary conditions, the starting rules for the whole system. The singularity isn't an object, it's the fundamental rulebook for whatever happens next.
We see this exact same kind of thinking in the holographic principle. Now this one is a real trip. It's this shocking idea that all the information needed to describe everything inside a black hole can be perfectly stored on its two-dimensional surface. It's like the 3D interior is just a projection. So again, a rule, a constraint on information, turns out to be more fundamental than the physical space it's supposed to occupy.
Okay, so let's pull back. If any of this is true, if reality is fundamentally made of rules, what does that mean for us? Well, it has some pretty huge implications for how we see the universe and even what knowledge itself is.
And it brings us right back to this famous, nagging question that physicist Eugene Wigner asked over 60 years ago. Why is math, this purely abstract thing that seems to come from our minds, so ridiculously, unreasonably good at describing the physical universe?
Well, Contraint Ontology offers a beautifully simple answer. Mathematics isn't describing reality from the outside, like an observer taking notes. Instead, both mathematicians and physicists are exploring the same fundamental landscape of rules and constraints, just using different tools and coming from different directions. It's no wonder their maps end up looking the same. They're mapping the same territory. And that implies that mathematics isn't just a clever tool we invented, it's an act of pure discovery. We're actually uncovering the logical architecture of reality itself.
So if you take one thing away from this, let it be this. The universe is not a big warehouse full of things. It is a journey. It's the navigation through a vast landscape of what is possible. And the geography of that landscape, the mountains you can't cross and the rivers you have to follow, is defined by a deep and beautiful set of fundamental constraints.
And that leaves us with this final, really powerful thought, a rewriting of our oldest stories. Because if this view holds up, then in the beginning, the most fundamental thing of all, it wasn't matter, it wasn't energy, it wasn't even nothingness. In the beginning was the rule, the constraint.